Now, if memory serves me correctly, I think I ended the lecture at the end of the floating point lecture. So I think we ended early, which means I'm starting from a fresh new set of lecture slides. I have an announcement to make before we start. If you haven't noticed yet, there is an assignment that was posted yesterday to the course OnQ. You've got a week to do it. So it's due next Thursday by midnight. It's not very long. The assignment has you, let me just pull it up. The assignment has you translate a Python program into a Java program. It tries to teach you a little bit about something called a cellular automaton, which is basically a regular grid of cells where each cell can be in one of a finite number of states. So our grid looks like this, and the state of a cell is just an integer number. And the integer number represents the number of grains of sand on each cell. And the idea is you're going to try to redistribute the grains of sand into the grid in a very particular way. So you get a Python program that does all this for you. And when you translate it into Java, you can end up producing pictures like this. Or you hit that link there, you end up, your program won't be able, well, can it do it? If you let your program run a very long time, it will eventually generate a picture like this. I don't know how long it'll take. It's probably going to take a very long time. But you can end up drawing pictures like this. For those of you who are curious or enjoy math or things like that, there's lots of links in the assignment that you can follow. You don't have to follow the links, right? But you can follow them to find out more about what's going on in the model that you're implementing in this assignment. Otherwise, it's a straightforward translation of Python into Java. So you get the full Python program, and you just translate the Python functions directly into Java methods. I think the assignment is relatively straightforward, so it should take you a few hours. Now, having said that, don't leave the assignment till next Wednesday or Thursday, right? You want to start it and make sure that you leave yourself plenty of time to do it in case you run into any issues. All right. So today's lecture is creating and using objects. Now, so far, all we've used are primitives and strings, basically, in the course. It's possible to write a complete Java program using only primitive values and maybe strings. Right? So it is possible to do that. Now, almost any non-trivial Java program, though, will make extensive use of objects that interact with one another. So why are we using objects? Because objects can perform more operations than simple primitive values. Right? So if you try to create a program using only primitive values, you want to do something complicated with them, right? Then you have to write your own methods that can compute whatever it is you want to compute using only your primitive values. If you have access to a large library of classes, though, those classes you can use the classes to make objects, and those objects have all sorts of abilities built into them. Right, which makes it easier to create a program that does something interesting, because you already have these pre-built objects that can do things for you. Okay. Now, objects can do things for you, so they have behavior, but they also carry information with them. So you know that a string represents a sequence of characters, right? So that's the information. That's some of the information that's stored in a string. The information that's in an object, it's just stored in variables. So there's nothing really new here. It's just that in an object-oriented programming language, information is organized differently than you would have organized it in the style of programming that you used in CISC 121 or CISC 101. Right, where there you have some variables. They might have been global. right? Or they might have been created in a function somewhere, right? And then you just pass those variables around. In an object-oriented programming language, the information lives in objects, and you pass the objects around. Now, that information that the object store, those are stored in variables that are called fields. So Java uses the term field or instance variable. If you're studying some other object-oriented programming language or object-oriented programming languages in general, the variables are often called attributes. So they are attributes that belong to objects, right? Your fields, they can be primitive type, right? So, you know, you can have your string stores a sequence of car, right? So you can sort of guess that a string might have an array of type car inside of it. Right? That may not be the way it's implemented, but you can sort of guess that might be the way it is. The thing with objects is once you, or the thing with classes is once you have types, reference types, right? Your objects can now contain variables that are also reference types, right? So your objects can be made up of other objects, right? And those objects can be made up of other objects, and those objects can be made up of other objects, and so on and so on and so on, right? So it's possible to build very complicated classes by layering objects on top of one, by having many layers of objects. The set of values of an object's fields, right? So you have your object has a bunch of fields. Right? The set of values of all of those fields, that's called the state of the object. So an object can also perform actions, and the methods that belong to an object define what actions the object can perform. And objects ask other objects to perform actions just by calling methods belonging to the other objects. Okay. So every object has information and it has behavior. The information is stored in fields and the behavior is represented by its methods. Right? That's all these two slides are trying to say. So how do you make and use an object? Well, an object has a life cycle. So to use an object, you have to make one. Right? So that's step one of object life cycle. How do you use an object? Well, you call methods belonging to the object. So while the object is alive, right, you can call methods. If you have access to them, you can use the fields of the objects directly. Usually you don't have access to the fields directly, but sometimes you do. And then when you're done with the object can be destroyed, right? Because the object has information with it in it, which means it has variables, right? Variables take up memory. So you need to release that memory back to the Java virtual machine, right? Otherwise, you'll eventually run out of memory. So you need to, when you're done with the object needs to be destroyed. So as a programmer in Java, you can have access to 1 and 2. You can control how an object is created, or you control the creation of the object. You control the use of the object. You do not normally control the destruction of an object. So the freeing of memory, that's the freeing of memory from objects that are no longer needed, that's all taken care of by the Java virtual machine. So there's a process called garbage collection that takes care of releasing the memory from objects that are no longer used. To create an object, you use what's called the new operator. So remember when we were making arrays, right, you would write new and then the type of the array and then the number of elements in the array. That was an example of using the new operator. The new operator does 3 things. So number 1, it allocates memory for the new object. So when you call new, a chunk of memory is allocated for the object that you want to create. Now, so you get a chunk of memory for the object, but now you need to fill in or define the state of the object, right? Because remember, every object has memory, has fields associated with it. So you need to set the values of those fields. Right? And that's the job of something called the constructor. So New then calls a constructor which initializes the state of the new object, right? So it gives the fields a value. It then finally, it returns a reference to the new object. That's why you can write something like an int array x is equal to a new int array of size 5. Right? So what does the variable x store? Well, it stores the reference to the returned object. Okay, so here's some examples of using new to create something called a point2 object. Okay, so point2 is one of these classes that we're going to look at in about a week, I think, maybe a little bit more. But we're going to actually create this point2 class. It's in the notebooks, so if you're already reading the notebooks, you can jump to part 2 and look at how how the point2 class is implemented. A point2 object is just a two-dimensional point. So it's just this thing that you should have studied in high school, right? And that represents the coordinates of a point on a two-dimensional Cartesian plane. Right? So in other words, it has an x and a y coordinate, and the x and the y coordinates, they're represented as double values. So here's, I have 3 variables, p1, p2, p3. Right? They're all of type point2, which means they're all going to store references to point2 objects. Right? I want to make 3 different point2 objects, so I'm going to use new, right? Call a constructor to create the point. Right? Now I've actually got 3 different constructors here. Right? So there's that constructor there. That's called the no argument constructor, and I'll explain why it's called that in a second. This one here, the third one, is called a copy constructor, and I'll explain that one shortly. And we've got a third constructor here, which doesn't have any special name. Now, over here on the right, I'm showing you what the coordinates of the created point are. So the coordinates of the first point are 0, 0. You can sort of guess that the coordinates of the second point are going to be 1 and 0.5, right? So that's x, that's y. There's a copy constructor. So what this constructor does is it copies whatever object this points to. So you can kind of guess that the coordinates of P3 will also be 1 and 0.5, right? The same coordinates as that object there. Here's an example. I'm going to skip ahead one slide, or a couple of slides. And I'll come back to this one. Okay. So when you call a constructor, when you use new, new is always followed by a constructor call. Right? So it has to be followed by a constructor call. When you make a new array, so when you say new int square brackets, that's actually a constructor call for an array. For other classes, the constructor, where is it? Here it is. The name of the constructor is always the same as the name of the class. So when we come back right here, right? So that's a constructor for the point2 class, right? How do I know it's a constructor? Well, it has the same name as the class, right? Point2 are also called point2, and they're always called point2. Now, when you call the constructor, you can pass in arguments to the constructor. So it looks exactly like a method call in Java, or it looks like a function call in Python. Example here, right here, I'm passing in no arguments to that constructor. Here, I'm passing in 2 arguments to this constructor, and here I'm passing in 1 argument to the third constructor. So they look like method calls, right? So when you call the constructor, it looks like you're calling a method. Right? What you have to remember in Java, though, is that Java does not consider the constructor to be a method. Right? So it looks like a method, not a method. One of the differences is that a constructor never returns a value, right? So methods in Java always return a value or void, right? Indicating that there's no return value. Constructor never returns a value, right? Not even void. Okay? So constructor never returns a value. When we get to when we start to implement constructors, you'll see that when you declare a constructor, it looks slightly different than declaring a method. Right? In particular, the return type is never listed. So the purpose of a constructor is to initialize the state of your newly created object. Right? So remember, we have a call new allocates memory for the object. Right? The constructor now fills in the memory with the state of the fields. So the no argument constructor, that's the constructor that has no caller specified inputs, right? So that constructor there, we pass in no arguments, right? That constructor is called the no argument constructor. The purpose of the no argument constructor, well, it's a constructor, so its purpose is to initialize the state of the object, right? The no argument constructor initializes the state to some well-defined default state. So for our point2 constructor, it initializes the point to 0, 0. So every time you use the no argument point2 constructor, that will initialize the point to 0, 0. Right. So our default state for points is the origin, which kind of makes sense. Now, not every class defines a no argument constructor. The point2 class happens to have one. The string class happens to have one. Many classes happen to have a no argument constructor, but not every class defines one. The only way you can find out whether or not the class defines the no argument constructor is to look at the documentation for the class. So we're going to do that a little bit later in the lecture. There's a second kind of special constructor called the copy constructor. So again, it's a constructor, so its job is to initialize the state of an object. It's called the copy constructor because it copies the state of another object of the same type. Okay. So copy constructor for point2, it has one parameter, right? The type of the parameter is also point2. Okay. So to use the no argument constructor, a caller passes in an argument of type point2. Constructor copies the state of whatever object is pointed to by that argument there. So in this example, the copy constructor here copies the state of the object pointed to by P2. Right? So what does P2 point to? Well, it points to an object whose state is 1 and 0.5. Right? So it points to the object whose coordinates are 1 and 0.5. So this copy constructor also initializes the third point2 object so that its coordinates are the same as the second one. Right? In other words, it copies the state of the passed in object. Now, not every class defines a no argument constructor. Right? Again, the only way you can find out if the no argument constructor is there is to look at the documentation for the class. Right? If a class defines the no argument constructor, though, it's telling you, hey, if you want to make a copy of an object, this is the way to do it. That's what it's saying. And finally, a class can define as many constructors as it wants, limited by a particular set of rules. Right? The rules don't matter for now. We'll learn about the rules later on. Right? But when you look at the documentation for a class, you might see 1, 2, 3, or many constructors. So the point2 class defines another type of constructor that lets the caller set the coordinates of the newly created point to some values that the caller specifies. Right. So that's that constructor there. This constructor here lets the caller specify the value of the x and the y coordinate. That creates a point whose coordinates are 1 and 0.5. Okay, so let's jump back now to that slide I had before. All right, so here's another example of using new to create a different kind of object. So in the package java.util, there's a class called scanner. Just a second here, I'm going to close my office door. All right, I'm back. So there's this class called scanner. Scanner is a type that can scan a stream of data. So for example, one type of stream of data is the keyboard. In Java, that's something called big S system.in. So what this actually is, it's what's called the standard input stream. On a desktop computer, the standard input stream is normally connected to your keyboard. So this is the way that you read keyboard input in a Java program. Right? You use a scanner object to process the stream of information coming in from the keyboard. So now I can use this variable s1 to call methods that belong to the scanner class so that I can read input coming from the keyboard. But the scanner class has other constructors. Right? So the scanner class can scan any stream of data. Well, not any stream, but any stream that it knows about, that it has a constructor for. Right? So for example, you can think of a string, right, as just being a stream of data. Right? It's just a stream of characters. So my string 1 fish, 2 fish, red fish, blue fish, right? I can pass that string to a scanner, and I can use the scanner to process the characters in this string. Right? So for example, one of the things you can do with the scanner is you can split, or I can read the strings that are made up in the string, right? Where they're separated by spaces, right? So I can use the scanner to get the 1, and then the fish, and then the 2, and then the fish, and then the red, and then the fish, and then the blue, and then the fish. Okay, so that's one way to process the string to get what are called the tokens of the string. Right? You can do something similar with the keyboard. Right? So I can read in individual strings that are being that were typed in by the user. Right, so back to our constructors, right? So there's the scanner class has a constructor that takes in the string. That takes in what's called the an input stream. And there's another constructor that takes in the string, right? And the scanner class is one of these classes that actually has several constructors. Now, once you've created your object, you're now able to use it. Right? So the way that you use an object is that you use it via a reference to the object. Right? Go back here. There's where I make my right. So new makes a scanner object. Right? This constructor initializes the scanner object to read the keyboard. Right? New then returns a reference to the scanner object that was initialized by this constructor. And then S1 stores the reference to the scanner object that was created by new. I can now use the variable S1 to access the methods of the scanner object on the right-hand side. Now, there is no way in Java to use an object directly. Right? So in Java, you always access an object via a reference. Right? The same is true in Python. So in Python, everything's a reference. So you access things in Python via references. So to use an object, normally what that means is you call a method belonging to the object. That's normally what it means. If the object has fields that are publicly visible or are visible to the caller, then you can access the fields of the object as well. But normally you access the methods. Right? So the way you call the methods is you use your reference variable, right? Then the dot, and then the method name, right? And then whatever arguments are needed by the method. Right? So the part here, right? Everything to the right of the dot, that just looks like a Python function call. Right? Now, there are no functions in Java, right? Everything belongs to a class or an object. So if you have a non-static method, you use a reference to the object followed by the dot. So using the point2 class, right? I'm going to make a point. I'm going to ask the point for its coordinates. And then I'm going to change its coordinates. So here's my point. So it's the point whose coordinates are 0.5, 0.1. Right, I'm now going to ask the point P, right, what X coordinate, right? So P dot X round bracket, right? So the point2 class has a method called X. It has no arguments, right? And that method X returns the X coordinate of the point. Method y returns the y coordinate of the point. Right? So here are variables x and y. Their values are just 0.5 and 0.1. I can now use x and y and change their values, right? So I can make x have the value 0.6. I can have y be the value 0, right? And I now want to change the coordinates of this point here to the new value of x and y. Right? So how do you do that? I need a reference to the point, so that's p. Need a method that can change the coordinates. So in Java, in the Point2 class, there's also a second method called x that takes in a double value. Right? So this will change the coordinates of the point referred to by p to whatever value that is. Right? So now our point's going to change coordinates to 0.6. Same with y. There's a method called y that takes in a double value that changes the coordinates of the point to that value there. Right? So after these two lines run, the coordinates of my point will be 0.6 and 0. There's also a method in the Point2 class that lets you change both coordinates at the same time. So the method set double values, and it sets the coordinates of the point to that and that. Right? The x coordinate to x and the y coordinate to y. Okay, here's here's a slightly more sophisticated example. Make a Point2 object. Right? So here's my constructor call. I'm going to set the coordinates to 0.5 and 0.5. I'm going to define a variable called the radius. Right? So this is the radius of a circle that I'm going to use to draw the point. Right? Now, we've got something new here. Right? So here, this is not new, right? So double radius equals 0.1. You should all know what that means. But the variable radius is declared to be final here. Also notice that it's written in all caps. The keyword final, when applied to a variable, when applied to a local variable, it means that you can assign a value to this variable only once. One more time, final variable name means that that variable, you can set its value only once. I'm going to set it to 0.1. I'm actually going to initialize the value of radius to 0.1 here. That means, because it's marked final, after this point, I can no longer change the value of radius. Right? So I can't, on this line here, write radius equals 0.2. Right? The compiler will flag that as an error. Right? So with primitive values, right, creating a final variable of primitive type means that you're creating a constant. Only set the value of the constant once. It doesn't have to be here. So for example, I can write final double radius semicolon. Right? Write a bunch of code, and then down here write radius equals something. Right? Once you write radius equals something, that's the last time you can change the value of radius. Right? So you're allowed to set it once and only once. When you declare a constant primitive value in Java, you can, if you want to, write it in all caps. Right? So remember, variable names are normally in lower camel case. Right? But if it's a constant, it is acceptable to write it in all caps. All right. So that's how you declare a constant primitive value in Java. Oh, question? What happens if you try to change it afterwards? The compiler won't let you. So when you try to compile your program, the compiler will say that you're changing the value of a final variable. So the program won't even run. Yeah, the program won't run. Okay, next slide. I've got this variable dx, its value is 0.01. So let me show you what happens when I run this program, because it'll be easier to see, it'll be easier to understand the program once I show it to you running. So let me just fire up Eclipse here. So what this program is going to do is going to make it's going to draw a circle, and the circle is going to bounce back and forth inside the window. Probably shouldn't show you that because that's the assignment. Let's see. Hopefully it's here. Oh, you know what? Sorry. I have to, I'm in the wrong workspace. All right, so what's going to happen here is I'm going to make a point. I'm going to draw it. It's going to bounce back and forth on the screen. All I'm going to do is I'm going to change the x coordinate of the point. I'm going to change it by that much each time step. So I'm going to ask the point for its x coordinate. Right. So when I first start running the loop, it's going to be 0.5, and then I'm going to move it to the right by that amount. I'm inside an infinite loop here, right? So I'm going to take px, right, the x coordinate of the point. I'm going to add 0.01 to it, and I'm going to store that value in this variable x. Right. I'm now going to check is x, has it reached the right edge of the window, right? So has the point reached the right-hand side of the window, right? And if it has, I'm going to reverse or negate the value of dx, right? So now dx becomes negative, and the point will start moving to the left. Similarly, if the point reaches the left-hand edge of the window, I'm going to reverse the value or negate the value of dx, so the point is going to start moving to the right again. Once I've computed the value of x, I'm going to set the x coordinate of the point to that value, and then I'm going to draw a circle. And so I've got this little program. I called it Pong because it sort of looks like the classic Atari game Pong. I don't know if you've seen it. It's an ancient game. It came out in like the 70s. And there you go. Right. So in a few lines of Java, you can do something like this. Now, the only reason you can do this is because someone's created the Point2 class, and someone has created the class called Standard Draw. So that class called Standard Draw, that is available to you, and it's also available to you in Assignment 1. So Standard Draw is it's a relatively simple class that lets you draw simple graphics primitives. So you can draw things like circles and squares and rectangles and other polygons. It's written by someone, a prof at Princeton University in New Jersey, who wrote a textbook, who wrote a Java textbook that used to be used there. I don't know if it's used there still. They haven't updated the textbook in some time now. Right. So you'll be using, there is, the Standard Draw class is available to you if you downloaded the source code for the course. So if you've downloaded the course notes, there's a zip file in the notes directory. If you import that zip file into Eclipse, so the way you would do it is file, I think there's instructions on the on-queue. Existing project, import existing project into workspace. And then choose the archive file, so choose the zip file. That will import all of the course, all of the classes that are used inside the course notes. Inside the class, inside the package geometry. I don't think you have the Pong class, but you can put it there if you want to. You have a different one. You have the projectile class or bouncing ball. Here it is. Okay, so you've got bouncing ball. So bouncing ball is a more sophisticated example of the one I just showed you. It does this. Right. So the way this works is it's similar to how the Pong class works, but instead of moving back and forth, it moves the ball according to ideal projectile motion. Right. So if you've taken a physics course before, you've almost certainly studied the motion of a projectile under the influence of gravity. That's all this is doing. Right. It's a little more sophisticated in the way it works, but otherwise the principles are all the same. Okay. So there it is there, right? So if you want to, you can open up that class and run it and study it if you want to see a more sophisticated example. Here's an example of using the scanner class. So I've got a scanner class called scanner example, right? I have a main method. I'm going to make a scanner. It's going to read the standard input. Remember, standard input is normally connected to your keyboard, right? And the way I'm going to use the scanner is I'm going to ask the scanner, right, while there is still another line of input to read from the scanner. That's what that line means there. I'm going to ask the scanner to return the line that was previously entered by the user. Right, so the way this program works is you run the program and then a console pops up and then you just get a blinking cursor. Oh, you know what, why don't I, let's run this example because that's easy enough to do. I can just copy it. Not all of the slide examples are available in the course notes. I shouldn't put it here. I'm going to put it here anyway just to save time. You know what? I'm not going to put it. I'm going to put it in the default. Okay, and I'm just going to replace the contents like that. Okay, so if you were to run this program, right, the way it works is you press run, nothing seems to happen. But if you click inside the console that's down here, you can see there's a blinking cursor. So the scanner, well, the program is just sitting here waiting for the user to type something in. Right, so I can type in something, right? And when you press hello, right? So hello, that enters a line, right? So has next line always returns true if it's connected to the keyboard, right? Because there might be, so has next just waits for the user to type something in, right? And press enter. After you press enter, right, you can ask the scanner for the line that was just input, right? So that returns the entire string that the user typed in here, right? And then on the next line, it just echoes back what was typed in, right? And then it comes back up, right? And it just waits for you to type in more input, right? Hello, how do I stop this thing? Right? I don't know. Right? Okay, so to stop this thing, you can press the little red button that's here, or you can type Control and C. Well, you should be able to type Control. I guess not in an Eclipse. If you're in a regular console, you could. But to stop it, you just press the Terminate button, and it now stops running. Right? Notice that the cursor stops blinking. Okay, so that's how you. That's an example of using the scanner. Normally, I don't like using. I don't like asking students to write programs that run in a console and ask the user for input. The reason I don't like doing that is because some students will get stuck in the mindset that that's the way, that's always the way you ask or you get input, right? So for example, I'll ask somebody, there'll be an assignment where you have to create a method, right? So the assignment will say, make a method that has a parameter of type int or of type string, right? And it does something with the int string. And so what ends up happening is students end up creating a scanner inside the method to get the string or the int, right? So in other words, there's a disconnect. What's supposed to happen is someone's supposed to call the method and pass in a string, right? But some students get trapped in the mindset that you always are asking the user for input, right? And so they create a scanner inside the method that, and they try to set the parameter to be equal to the string. To be equal to whatever the scanner reads in. So if you look at the scanner documentation, you'll see that there are different methods to get input, right? So here, next line, that returns the entire line of text that the user typed in. If you just want to get a single int, you can use next int, right? If you just want to get a single string, so a string, so it'll separate it with spaces. You just use next. So the answer is look at the scanner documentation and see what methods the scanner has. Okay. There is a next int, there's a next double, there's a next boolean, or next bool, I don't remember, and things like that. But the scanner has methods to do all that. Now, if you want the, it's not obvious how you make that program stop, right? So the sensible way to make the program stop is to look at the input, right? So after you get the input from the user, right, you can check if the input is equal to some sort of stopping string, right? So here I'm going to check is the line equals to quit, right? And if it is, I'm going to break. So let's do that. So let's modify our program. So if, whoa, oh wait, that's not our program. Hang on, sorry, that's the PowerPoint. there's our program. Okay, so if line equals, you can choose whatever quitting string you want here. Right? I can break. Break will break out of the loop that it's inside of. Okay? So it'll jump out of this loop and end up down here. Okay, so now I can do hello, right? Entered hello, and now if I hit quit, the program stops, right? So it's hard for you to see because it's small, but that says terminated, and that red square there is no longer red, right? So the program is no longer running. Incidentally, that is the way to tell if a program is running in Eclipse, right? There will be if that square there is red, your program is running, right? So there it is, right? And you can always you can always stop the program by pressing the red stop button. Okay. So how do you know what a class can do, right? Or what methods a class provides? Well, it's documented. All of the standard library classes are documented online. So here is a link to the documentation for version 8 of the language. Hey. Sorry, got a cat. For version 8 of the language. For the purposes of this course, anything above any version of Java 8 or above is fine. Okay. You want to avoid using stuff from that's earlier than Java 8. But otherwise, anything from 8 or beyond is fine. So if you actually click on that link, hopefully this works. It does. It'll take you to this page here. And this page here, you can see, is kind of organized in a particular way. So this takes you to the home page for the standard 8 edition, the documentation for the standard 8, for the version 8 of the language for its standard libraries. Right over here, you can see all of the packages that come in the standard version of the language. Right, it's enormous. Right, inside each one of these packages are more packages and classes. Right now, don't be afraid that there's so many of them. We're not going to look at most of them. Right, most of the stuff we look at is in Java Lang and in Java util. Where's util? Here. Right, so those two packages are the ones that we're mostly concerned with in this course. So if you click on Java Lang, for example, down here, it'll tell you, ignore the interfaces for now. We'll come back to that later in the course. It'll show you all the classes that are defined inside of Java Lang. Right, so for example, the string class is here. Right, the math class is here. Right, the class big O object is here. So Java Lang is the package that defines the classes that are considered fundamental to the programming language. So if you click on string, right, you get the documentation for the string class. Let me go to util because I want to look at the scanner class quickly. So here's util, right down here. You can scroll and find, notice there's quite a lot of classes here. Util, these are the useful classes, right? These are the generally useful classes. Scanner is one of them, right? So when you read the documentation for scanner or for any class in Java, it always looks like this, right at the top. I'm not sure what compact 1, compact 2, compact 3 is. I believe that's a bug, but anyway, I'm not 100% sure where that is. That tells you the package that the class is defined in. That tells you the name of the class. This shows you what's called the inheritance hierarchy for the class. We're not concerned with this right now. And then next is a description of what the class is supposed to be used for. So the Java standard library tends to be very detailed in its description, right? So you notice it goes on for quite a long time. The classes, all of the classes that are in the notebook, they're also documented, but their descriptions aren't nearly as long. Once you get past the description, right, notice it's very long, right? You'll find the constructors, and you can see that the scanner has a whole bunch of different constructors. Okay, so you can create a scanner that can read a file, right? It can read an input stream. So this is system.in is considered to be an input stream. Path, that's another way to read a file. String, there's how you read a string. Right? So there's constructors that can do a whole bunch of things. A lot of these constructors are reading things or are parsing things that we don't have time to cover in the course. Right? And then as you scroll down more, you'll see the method summaries. Right? So in the method summaries, you need to pay attention to the thing on the left-hand side. Right? So the thing on the left-hand side, that's the return value of the method. Right? I just want to quickly scroll through. Notice there's lots of methods. Right? I just want to, okay. So the scanner class does not have any static methods. Right? So everything in the scanner class is non-static, right? All the methods are non-static. That means you always need a scanner object to call any one of these methods. Right? So remember, a static method you call with a class name. Non-static method you always call with an object reference. If you scroll down, you'll see that there's has next line, right? So has next line. There it is. So there's the method has next line, right? And it returns the Boolean value. You click on the method, right? So anything in blue you can click on. It takes you to the further down in the documentation, and you can see the detailed documentation for the method. Right? Now, in the detailed documentation, you'll see that the return value is documented. Right? So this method returns true if and only if the scanner has another line of input. Right? It'll also tell you if the method throws any exceptions. So has next line will throw an illegal state exception if the scanner has been closed. Right? If a method has parameters, then that will also be documented in the detailed section. So let's scroll down. Let's find a method that has some parameters or a parameter. No, you don't want that one. Next. Next. Are there any good ones? Let me jump to the string class instead, because that one's a little easier to understand. So here's string, right? Same thing, right? Name of the class, package it's defined in, description of the class, right? Constructors. Oh, if you ever see deprecated, deprecated means that you should not, this constructor should no longer be used. It's still usable. It's just that you should no longer use it because a later version of the language may remove it. So in case you're wondering what that means. Okay, so here's car at for string, right? Car at takes in an index. Click on the method, right? There's your parameter. So that's documented right here. Okay, so it tells you that the index is the index of the car value, right? The return type is documented here, right? So car at returns the car value at the specified index. Yeah, I'll post the slides. I'm a little bit behind on updating stuff. But yeah, I'll post the slides and the previous lectures as soon as I find time to do it. And any exception that it might throw. Right? So that's the quick introduction to how to read an API. There is a notebook and a video that also takes you through the process of reading an API. Just before I shut things down, well, I'm going to stop the lecture there. But if you have downloaded the course source code, right? So inside your CISC 124 project contains all the source code that is in the lecture books, in the notebook, sorry. You will see a folder down here called doc. Inside that folder is all the documentation for every class that's in the notebooks. Almost every class, right, is also documented. Right, so if you go to Notes Basic Geometry, you can find the documentation for the Point2 class. Right, so it's all there. All right, so I'm actually slightly over time, so I'm going to end the lecture there. Anybody have any questions before I go? I have time for one or two. Okay, I'm not seeing anything right away, so I'll stop the recording there.